This is one of the introduction videos on Linux basics and internals. Primarily covering how the Linux file systems and Linux basics will work, how it will really put on a given microprocessor or SoC, how really different components of Linux will make up for making proper Linux bring up on a given microprocessor unit and or basically on the SoC. And there is for any Linux system there are primary requirements are there, like if you look at except there are music Linux which came into picture where it can also support a MMU-less controllers, but most of the general Linux kernel requires MMU based microprocessors, and some of the other minimum requirements MP should hold such a way that we can boot the Linux on the system. Now if you look at the Linux, primarily Linux also requires a Linux operating system as such. Basically either we can call it a operating system or a distribution, because a Linux kernel is maintained by separately by the Linux kernel team, Linux kernel.org, and the file system. File system we will have a lot of opportunities, and both are maintained separately actually. That way some company which can merge these things can build the solution and provide a generic a system to use, like a desktop or a mobile operating system or a tablet operating system or desktop or server operating. They are called as distributors. Primarily there are a lot of big players in the Linux distribution world. For example, Ubuntu, which is canonical, and Red Hat, SUSE, and there are a lot of players are available in the Linux distribution world, and there are hundreds of Linux distributions which are open source and maintained, like Debian, Arch Linux. There are so many other distributions are available. If you look at the Linux, it contains multiple components. That means on any Intel CPUs or ARM or RISC-V CPUs, it requires some of the basic components like bootloader, and then the even Windows also, if you take in the sense, it requires bootloader, and then above the bootloader Linux, other stuff of the low level stuff of the Linux kernel will get initialized, and Linux kernel will set up all the required base tasks or the kernel threads and whatever required for the building your applications. That means now I will primarily focus on the Linux applications, how we can run a Linux application, and how to application what Linux provides is a framework, that is a proper planned file system, root file system we call it as. This root file system is a Linux file system which is structured, well structured, and most of the distribution vendors and the industry follows some LDH standards to make sure, and LSB standards. These LSB standards are primarily required because to retain a proper base for the Linux file system adhere to the Linux file system. This Linux file system is above this we can always add our applications, and we can integrate our applications. To integrate our application and add our applications, either we can compile our application through a compiler, and we can integrate with the while we are starting the system or whatever. There are a lot of ways provided by the vendors to start the application at the boot up time and other ways, but other way is that you can always use package managers provided by the distributed vendor, and we can build a custom packages and we can integrate with the device. And if you now start looking at the Linux as such,